Hi, Kristen Atchison here, and we're going to be reviewing 3 claims and 4 validities. So the 3 different kinds of claims that researchers make and the 4 validities that we use to interrogate them. This is really helpful tools for you reading research. So as a student of psychology and as a consumer of research, these are really important skills. So back to your intro psych review. We have different designs that we use in designing research. The main 3 that we're going to talk about are descriptive research methods. Those we do to observe and describe behavior. That includes the naturalistic observations, the case studies, the surveys. We also have correlational methods, which look at the relationship between 2 or more variables. Both of these 2 you talked a lot about in your previous research methods course. And the one that we're going to spend the most of the time on in this course is experimental methods. This is the only way that we can look at cause and effect relationships. So, all of these kinds of studies have variables. What is a variable? Very simply, it is something that varies, right? That's where it gets its name. It changes in some way. So it has to have at least 2 different variables. It has to be 2 different levels. It has to be able to be one thing or another thing. It has to have some capacity for change in it. If it's something that's just held constant, it's not a variable. Then it's a constant. So variables have to have that ability to change. There's different kinds of variables, and the kinds that we're going to talk about primarily in this class include measured variables. That could be something like a subject variable, so male or female. It could be something like in an experiment with a dependent variable, something that you're measuring something, you're measuring some sort of behavior, you're measuring some sort of opinion, you're measuring something. And the other kind is a manipulated variable, and this is what we're going to talk about a lot in our experimental methods, because in experimental methods, we're manipulating variables. In our other methods, we're primarily measuring variables. We're either measuring 1 variable or we're measuring 2 variables, and in an experiment, we're both manipulating variables and measuring variables. So again, measured variables are observed and recorded. There's nothing that the researcher is doing to them. There's no way that they're affecting them. They just want to look at them. They just want to pay attention to them. They just want to observe them, and they want to record that information. That's all the researchers are interested in doing with measured variables. Manipulated variables, however, are controlled. Those are where the researchers are trying to cause some difference between them. They're trying to do something different between different levels of that. Now, they may be trying to manipulate something so that they can cause change on a measured variable, but the measured variable is still just being observed and recorded. It's that manipulated variable that's being controlled in some way. There are some variables that you can only measure, but not manipulate, right? So I can't manipulate whether you're male or female. I can't manipulate your ethnic identity. I can't manipulate a diagnosis, whether you have a diagnosis or not. Those are only things that can be measured. I can't manipulate your height. I can't manipulate your weight. Those are measured variables. Some things can be either manipulated or measured. And it will depend on the kind of study and the kind of research question as to what is what. So to review the 3 claims that you've covered previously, we have frequency claims, and those are those descriptive methods that we talked about. We have association claims, which come out of those correlational methods. And we have causal claims, which come out of experimental methods. So examples of these from your textbook say, so a frequency claim, 1 in 25 U.S. teens attempt suicide. 79% of people think regifting is acceptable. These are frequency claims. They're telling us about the frequency of something. They're describing something. They're describing some sort of data. And an association claim, they're taking 2 or more variables and they're trying to show relationships between them. So their mixed weight couples argue more. So they're looking at arguments and they're looking at the weight of the couple. Those are two different variables. We'll look at bedroom TVs and children's risk of fat and subsequent disease. Those are multiple variables that they're trying to make an association between. And causal claims are where we're trying to say that one variable is causing change on another variable. We're looking at cause and effect claims. So music lessons enhance IQ. They're saying that music is causing that change to IQ. They're saying that the shape of the glass will influence how fast you drink. They're making a claim about a cause and effect relationship. So in frequency claims with those descriptive methods, again, we're describing a particular rate or a degree of a single variable. We're only looking at one measured variable in frequency claims. We're looking at one thing, we're measuring it. And we're describing the frequency of it. That's essentially, in a nutshell, what frequency claims are. And you can see how those are going to be the easiest and the most simplistic kinds of research methods because we're just looking at something and we're measuring it. Association claims get a little bit more complex. We're looking at correlational methods. We're trying to say that one level of a variable is associated with a particular level of another variable, that these two things are correlated. These two things change together. These two things change apart. As one goes up, the other goes down, or as one goes down, they both go down. And they're saying, again, that there's two or more measured variables that are associated or correlated in some way. Now, we make predictions based on these associations. We can take these associations and we can make guesses, we can make predictions, we can make a hypothesis about what we think is going to happen based on what we know about this association. So think back to a correlation, right? You get a line. Well, if you know one place on the line and you have one data point, then you can predict what that other data point's going to be. You can predict the value of that other data point based on this correlation, based on this association. The stronger the association between these two variables, the more accurate the prediction. So if you had a really, really strong correlation, you had more power to make a strong prediction. And you can have positive correlations, positive associations. You can have negative correlations. You can have negative associations. And they can help us make predictions. But when there's no relationship, we can't make a prediction. Now, it wouldn't be any conversation about correlation without reminding you once again that correlation cannot prove causation. This is why association claims are different than causation claims. That's why they're completely separate, because correlation cannot prove causation. It cannot imply causation. So we know that ear hair and heart attacks are correlated. Does that mean that ear hair causes heart attacks? Does that mean that heart attacks cause your ear hair to grow? No, right? Neither one of those things do we think is going on. There could be an unmeasured common factor. And in the case of ear hair and heart attacks, it's probably likely that age is that unmeasured common factor. You're more likely to have ear hair as you're older. You're more likely to have more heart attacks as you age as well. So your risk for both of those things goes up together. It's not that your ear hair is causing heart attacks or heart attacks are causing ear hair, because that would be strange. But it's this unmeasured factor. And this is why correlation cannot prove causation. This is a really great table from your textbook. It's table 3.3. And it's a really good way when you're reading the literature to differentiate the kinds of claims that they're making. They're not going to come out and say, I'm making an association claim that X is related to Y. They're not going to say that. They are going to say related to, right? They are going to say correlated with. They are going to say associated with, may predict, is tied to. Those are those association claim verbs. Where causal claims are going to say cause, affects, exacerbate, changes, adds, fights, distracts, prevents, reduces, It's saying that there's more than just a relationship going on here, that one is causing change or is likely causing change in the other. So when you're reading the literature, those are the kinds of claims to keep out for. So when you go back and you're having to identify different kinds of research designs, go back to this table. It's very, very helpful, table 3.3 in your textbook. So, causal claims, experimental research. Experiments must include an independent variable, and that independent variable is manipulated, okay? The researcher is manipulating that independent variable. An experiment must also include a dependent variable, and that dependent variable is being measured. And any other variable is extraneous. Anything else in the study is not of interest and needs to be controlled for in some way. So in this graph here, the researchers were looking at what role music class has in IQ, okay? So they had two different kinds of music classes and two different kinds of non-music classes or no music class, and they had various levels of both. So they had keyboard or voice classes for music, they had drama classes or no lessons for control, and then they measured IQ. Okay, so our independent variable is whether they got the music classes or not. And there are 4 different levels of that. There's no lessons, there's drama lessons, there's voice lessons, and there's keyboard lessons. And then the measured variable is the IQ. They're just measuring that. And that's why you see on that part of the graph, that's where we see the numbers, because that's what's being measured. So that's a really easy way when you're looking at a graph to figure out which one's the dependent variable, is what's being measured. Where are the numbers? Where are we seeing those measurements? And then another component that we'll talk about more as this course goes on is random assignment. So experimental research has random assignment, and we'll talk about that more in detail later. Also in causal claims, we're going to have a hypothesis. Other research has a hypothesis as well, but when you look at a hypothesis, you can pull out the independent variable and the dependent variable by looking at that relationship with those causal claim verbs. So here our causal claim verb is increase, okay? And we're saying that knowing the title of the paragraph will increase memory retention. So the title is our independent variable. That's what's being manipulated. If you know the title, that will cause change, increase, to our dependent variable, memory retention. So our independent variable is whether or not the title is given, and that is our manipulated variable. We're either giving people the title or not giving them the title, okay? We're manipulating that information as researchers. Our dependent variable is the memory for the paragraph, that retention, and that's what's being measured. They don't have any real ability to change that, right? They just measure that. They're just observing that. Now, they are manipulating whether or not they get the title to see if that causes change to memory retention. That's how we'll look at these kind of hypothesis. So when you're reading literature, look for those kinds of things. Look for those claim verbs, and then look at the relationship of those 2 variables that they're talking about. In an experiment, which one's the independent variable, which one's being manipulated, versus which one's the dependent variable and which one's being measured. So when we're looking at research, we need to be able to interrogate frequency claims, we need to be able to interrogate association claims, and we need to be able to interrogate causal claims. And how we're primarily going to do that is by looking at the validities of these claims, okay? So validity, what does it mean? It means, is it valid? Okay, well, what's valid? Valid can mean a number of different things, but when we're thinking about research, it's things like, is it well-founded? Is it sound? Is it viable? Is it defensible? Is it logical? Is it rational? Is it justifiable? Is it solid? So we're looking at, is this thing what it says it is? Okay? And we can look at that in different ways. One of the ways we can look at that is construct validity. Is the quality of the measure, are the measurements and the manipulations what they say they are? Are we actually manipulating what we think we're manipulating? Are we actually measuring what we're seeking to measure? So if we're measuring IQ, but we're measuring IQ by looking at foot size, we have really terrible construct validity. We're not looking at IQ. If we're defining IQ as the size of your foot, we've messed some things up, right? So it's the quality of that construct, how well we've defined that, how well we are actually measuring what we're seeking to measure and manipulating what we're seeking to manipulate. Another one of those is statistical validity. Are our conclusions appropriate and reasonable? And we're going to spend pretty much the entire half of the class talking about that, okay, when we're talking about the various statistical tests. But you've got a lot of statistics coming into this course, and so you can evaluate those as well. You can evaluate correlations. You can evaluate, should they have used a correlation here? Do you think that that was an appropriate test for the kinds of claims that they're making? If they're making a causal claim, correlation's not the right test. You don't have statistical validity. So are these appropriate? Are these reasonable? Are these logical? External validity is another one that we talk about. So to whom, what, or where can we generalize? So the way I like to think of external versus internal validity is external is, can we apply what we find outside of the research? External to the research. Can we apply what we find outside of it? Okay, is it solid? Is it credible outside of this bubble of the study itself? Okay, so can we generalize it to other people? Can we generalize it to other groups? Can we generalize it to other settings? Are we able to do that? Are these findings true? Are these findings logical? Are these findings reasonable outside of the research? And the last one that we're going to talk about, primarily in reference to our experimental research designs, is internal validity. So that there is no other possible causal explanation for the outcome. It can only be that our manipulation of the independent variable caused this change on the dependent variable. Nothing else could be possibly going on. And we'll spend a lot of time talking about that in our next chapter. Okay, so internal validity is the study rational, logical, sound, viable, credible, internally, right? Is the claims that we're making, are they viable? Or are they credible? Or is there something else going on that we didn't think about? Is there something else going on that we didn't control for, that we allowed to vary with our independent variable that's showing up as this false effect? Do we have internal validity? Can we say that our manipulation of the independent variable caused the change on our dependent variable? So in interrogating frequency claims, how well was the variable measured? Did we measure what we sought to measure? Did we do that appropriately? External validity. Can we generalize this to more people? You took a sample from the population. Was it representative? Did you just take, white 18-year-old males? Well, that's not representative of the population of adults, right? And that was a problem that we had in a long, long time ago in psychology research. They weren't taking representative samples. So can we generalize this finding to the population? And statistical validity. Is our margin of error? What's our margin of error? If we're saying that there's this many people doing X, Y, or Z, but our margin of error is bigger than the number of people that we're saying, we've got a problem. And so we need to look at those things. Association claims. Again, this is all what we're doing when we're reading the literature. How well were each of these variables measured? We're looking at 2 or more variables here. Did we measure what we sought out to measure? Did we do a good job of making that measurement? Did we define it properly? Do we have an operational definition that is consistent with what we're actually trying to measure? Is it reflective of the thing that we're interested in? Statistical validity. How strong was this association? Look at that correlation value. Look at that R. Does it work? Does it? Is it strong? Did we get a strong association, or are we a very, very weak association? Is it statistically significant? Did we hit our 0.05 cutoff? did we surpass it? Are we at 0.001? That's excellent, right? So where is that? Is it statistically valid? And again, externally, to whom can we generalize this association? This may be less important to the researcher if they're just trying to kind of begin to make associations between these things. So they may use a less representative sample for an association claim, because if we're finding an association between this smaller group of people, then we might be more likely to find it with a bigger group of people as well. But it's kind of a baby step thing, right? And as we talk about later when we get to experiments, you have to have association claims before there's any point in even looking at causal claims. Because if two things aren't associated, then one's not causing the other. And so we're going to have to look at those things together. Interrogating causal claims. We'll just real quick go through this because we'll spend a whole nother lecture just talking about that in this course. So did we manipulate what we sought to manipulate with the independent variable? Did we measure what we sought to measure with the dependent variable? That's our construct validity for an experimental study. How big is the difference? Is that difference between our two groups statistically significant? That's what we're going to do with t-tests. That's what we're going to do with ANOVAs. We're saying how big is the difference, and would we have found that difference due to chance? Are you using the right test? Are you using the most conservative test? Are you using a least conservative test? These are the kinds of things that we're going to talk about when we get to t-tests and we get to ANOVAs. External validity. Again, can we generalize this effect? Now, we don't spend a lot of time worrying about this in experiments, and that can be problematic. But the reason that we do that is because internal validity really is our priority. And as you'll see when we have an entire lecture dedicated to internal validity in experimental studies, there's a trade-off between those. When we control everything so that we can say that it is only our manipulation of the independent variable that caused change to our dependent variable, that kind of control isn't very world-like, right? That's not what the real world looks like. That kind of controlled population is not what the real world looks like. And so we limit our external validity by pumping up our internal validity. And so there is this give and take between those two that we'll talk about later. So that was our review of our 3 kinds of claims: frequency, association, and causal, and our 4 kinds of validity: construct, statistical, external, and internal. Thanks.